Good afternoon to everybody. And this presentation is quite long, but part of this is covered by the other presentation. So I skip many slides and probably become short. I hope like this and to stay in the time. Anyway, this is, okay. You can see that there are a lot of subjects, but many of these subjects, as I said before, are covered by presentation already given, by the presentation that are going to be given. So I do think that I can try to be fast. The drivers, why we are going to the LNG as fuel. We said this morning is just to comply with the new regulation relative to the emission, and also because there are some economics. The gas is less expensive than oil, and probably everything says that in the future will be a big quantity of gas coming, and so the gas should cost less than oil. These are the drivers. And of course, these are all the pollution and emission regulations that have been illustrated this morning, so I don't believe to spend some time here. Anyway, you can see here in this presentation. Now, which are the option to comply with this regulation? Of course, the first option is to use distillate fuel, but of course, this should be very expensive, and there are not enough distillate fuel to comply with the regulations here, if all the ship is going to this. Then there is the use of scrubber, this has been talked before. Then there are advanced technology for the reduction of NOx, and after treatment systems, and also there is, of course, the energy fuel solutions. This is, okay, this is one. No, okay. So these are the problem. Something to be clarified is that actually energy is not like in the normal fuel. There are some differences, something that makes energy quite different with the fuel we are used to today. And these characteristics are, first of all, the very low temperature at which energy should be loaded. This is less than minus 160 degrees centigrade. This means that the LNG creates a problem. In case of leak, you can have brittle fracture. You can almost impair the strength of the ship. It is very fast, the brittle fracture, if the steel comes into contact with cold energy. And there is another thing. Energy to be kept at this temperature should be kept as a boiling liquid. So you have the liquid continuously boiling. That means that you have generating vapor. This is the boil off. And this boil off is to be handled in some way when it is not used for the fuel. For instance, during the idle times of the ship or something like that. Also, another thing, this we can say back in the next slide, is the, so that means that it is all the energy handling system are to be put in the hazardous areas. And what I will say, the composition can vary. The problem is this, the natural gas is a mixture of hydrocarbons and with a large quantity of methanes, normally more than 80%, normally more than 90%, but it can be more than 80%. It happens that in this mixture, these gases have different, there are lighter gas and higher gas. So practically, the first of these gas that vaporize are the light gas, especially methane, and then after the heavy gas. So that means that after a certain time, a long time, the composition change. It becomes heavier, and the temperature increase. And with the increase of the temperature, increase also the pressure. So these are phenomena that have to be taken into account whenever you deal with energy. Another problem is this, that there is not one energy. Energy, I would say that there is a combination of different gases, And these gases depends on the natural gas where they are coming from, so from the well and then from the process of liquefaction. That means that all are different, and this means also that the energy content can change. It is difficult, so, to sell, to find a unit for selling the LNG. At the moment, the LNG is sold as function of the energy content. So the unit that is used to selling LNG is BTU. BTU is very small quantity of energy, so it's a million of BTU. And this is something that can be good for power station or something like that, but it's surely not good for the normal bunkering. For cars, for instance, it's sold in kilos. And so it is the problem that at the moment there is not a standard to establish how the LNG for bunkering should be sold. And so this should be decided case by case. And waiting for a standard, this is something that also can create some problems. Look at the cargo, the bunker containment systems. Practically, these indicated slides are all the cargo containment systems that are available today. Practically, from a certain, generally speaking, any one of these cargo containment systems might be used to load the bunker in a ship. And maybe something, some of these are some advantage, some are disadvantage. What is important to find the best compromise depending on the type of ship. The types that are more considered suitable is the independent tank type C. These are pressure vessels, and there is some advantage. They have no secondary barrier. They can be designed for high pressure, and the boil-off, the vapor that is generated continuously, can be kept inside the tank. So there is no necessity to dispose this because the tank can be designed to withstand the increased pressure of this boil-off. Also, another advantage of the Type C tank is the fact that working with the pressure, you can regulate the pressure inside the tank, the temperature, and you can also feed the engine without pumps, without compressor, just by the pressure, just opening the tap. This is something that is an advantage of this. And we have prismatic tanks, or tanks that follow more or less the shape of the hull. This is an advantage that they have, are quite efficient as far as the volume, because the Type C tank are not efficient as far as the volume because it is just a cylinder inside an old. It's a lot of space that is not usable. And also the membrane tanks, Professor GTT is making proposal now for using for the membrane tanks for bunkering system. And these are very effective for utilizing the available space, and they require a secondary barrier, and also the problem that cannot be pressurized, these tanks. A big problem of the tank is the volume, because the LNG requires much more volume than normal fuel as far as consider the same energy that is being released. For instance, you can see that the volume of LNG necessary is equivalent to have a certain quantity of energy is equivalent to about 1.6 times the volume of the normal fuel. So practically the tank should be larger. But it is also to be considered that the tank is to be put, if it's put inside an old, you need the space for the insulation of the tank, you need the space all around the tank, etc. And so if you have a Type C tank, so a pressure vessel inside the old, the volume, the gross volume necessary to transport the certain quantity of energy with LNG is about 4 times the volume of the normal gas. So this means that putting these tanks inside the hull is something that can be very penalizing in terms of volume. You can lose cargo capacity of the ship. the tank can be located above the deck or below the deck, and the minimum distance from the side shell should be B divided 5 for passenger ships. For non-passenger ships, this can be reduced. But how much? We apply the IGC code for this, so practically we say from a minimum of 800 millimeter to 2,000 millimeter, depending on the volume of the tank. And this is also for the tank inside the shell. For the gas conditioning preparation, okay, we need some equipment. This equipment can be located in a certain space that is out of the engine room. And this is but for small LPG type C tank. This can be just a kind of protrusion of the tank. It's called cold box. And all the equipment come together with the tank. And this is what you can see here. There are some examples of this. If the engine is made by slow speed, is an engine that requires high pressure, of course, we need a high pressure compressor to increase the pressure to about 300 bar. That is what there is a need. Bunker station should be provided, should be apply a safety system to assure that there is no discharge of any particular gas, and the remaining LNG tank are likely to be at higher point. This is the problem, the bunker transfer. Bunker transfer, I think that there is another presentation, so I have only 3 minutes, so I skip this part. And for the regulation, these are the regulation of the MARPOL, you say already this one. And the gas code, what apply. At the moment, there is an IMO interim guideline of safety of natural gas fuel energy installation of ships. This is a draft. This is not mandatory, but it's the only document of IMO that is available now, waiting for the new GF code that will cover this. The IGF code is still under discussion. It was supposed to enter into force in 2016, but surely will not. And practically, this will be made in 2 parts. The first part will consider the natural gas and methanol, and the second part, this is the one that is delaying the entry into force of this, because it is under study at the moment, will cover also other gases, like LPG, for instance, etc. This is what happened. The IGC code is something that is not applicable theoretically to dual fuel ships. Is applicable only to gas ships. And anyway, a new version of the gas code will be entered into force in 2016. ABS has published a guidance for propulsion and auxiliary system for gas fuel ships. This is being published in 2011. It's being updated continuously. And this one is more or less under the guideline of the IMO interim code. And what else we have? There are another thing that is not regulated by IMO is the interfaces between the bunkering station and the ship. All these, there are some industry standards that are coming, and practically at the moment we don't have an IMO standard, we have also these interim standards that are listed here. We have the ISO, that is a high-level document that gives only the drivers, and there is EMSA that make a kind of study, West Coast policy, and especially there is SICTO that gives guidance for ship-to-ship transfer of gas, and there is Intertanko, SIMNAC, etc. 27 seconds. Okay?